All right, so welcome after the short, way too long break. I'm Matthias Friedrich, and I want to talk about our experience building our first Flutter app at Jimdo. First, a little bit about myself. I'm an Android developer since 2009, directly when I could get my first hands on a real device. Back then, the first Samsung Galaxy, not the S, but the Galaxy. And yeah, since then, I worked on lots of apps, hybrid apps, featured native apps in the Play Store, even completely custom Android software for custom environments. And yeah, but as I am a real die-hard Android developer since then, I was never convinced by any solution that went cross-platform or hybrid. But yeah, let's go on. And it has some reasons that I was never convinced. So especially when native developers see cross-platform hear cross-platform, they think, yeah, that can't be it, because there are several reasons. For example, cross-platform applications often don't feel native. The UI doesn't feel like it should on an Android device, on iOS device. It often feels wrong. Then there's often, when the cross-platform framework uses native UIs under the hood, it needs to bridge the development language that the developer is building the app in to the native development tools, and that creates an update gap. For example, when Google or Apple are updating the native SDKs. So it takes time until latest UI features are available into these new cross-platform tools. The same is valid for hardware integrations. When you, for example, want to approach an NFC reader or something like that, it takes time until these things are available to the cross-platform development tools. And of course, another big disadvantage cross-platform tools often have is that the performance is just bad. It's depending on how they are done exactly under the hood. They need to bridge to the native development tools. They often depend on JavaScript that is being interpreted, and with that doesn't run as fast as native compiled code. And all this then results in bad developer experience. And this then is often the result. So you have to choose. Go real native, build lots of complex things for the different platforms, but have a really good outcome, a shiny castle, or do some cross-platform tool, and the result will, yeah, not as good. Will be not as good. But okay, some more context regarding us. We are Jimdo. Our main product is a do-it-yourself website builder. So our main product with that, out of the nature of the product, is in the web. But we still have several native applications for Android and iOS. Yeah, these four. And the biggest one, the creator, has more than 1.2 million installs on each of the platforms, and we got featured by the Play Store. So yeah, but we still are two developers inside the team. Why two? Because our management first thinks that small teams can move really fast, and that's what they want. And our main money driver are not these apps. So the reason why we are building mobile apps is to push the brand awareness from within the app stores, and also to upsell our products. So with the mobile apps giving additional features to our core product, the website builder, but also to engage our users when they are out, when they are mobile. For example, giving shop notifications about their online shop and so on. Yeah, and we have a really progressive culture at the company. Our management constantly tells us to move fast to break things. They want to push us to use new development tools that are promising. Yeah. And so we went ahead and we wanted to build a new app for we internally changed the whole product, moved away from our old legacy product and moved to a new one. And for that, we wanted to build a completely new app as well. And that was Jimdo Boost, a new companion app for website owners in our system. And we knew from the start that this app would be not dependent on deep system integration like NFC readers, Bluetooth, location awareness, and so on. So our app is mainly about showing people content out of our system, so basically from our backend. And also, as our main users, or for this app, all our users actually, are using our web product anyway, we wanted to not focus on platform-specific UI and design, but to push our brand and bring our brand design, which we created over the last 2 years, into mobile as well. Before we didn't do that, especially because we were just 2 developers per platform. We said we keep it to the platform to be consistent. Yeah. So all this sound as good reasons to try a cross-platform solution. And then, yeah, there was Flutter around. It was end of last year when Flutter was still in alpha. And of course, it has the promise to write once and one on several platforms. And it features a really new, modern, reactive, and highly customizable UI framework. And that was really promising, especially regarding our intent to push our brand design instead of the platform. And yeah, it promises really fast development with hot reload. And what I especially like personally about it is that it has, although it's cross-platform, it has native UI performance, and it's completely platform independent on the UI stack. So when you build a Flutter app, whatever you do there, it will and look exactly the same, be it a Samsung device running Android 4.1, even Samsung, we know there were lots of troubles with Samsung, or be it a Pixel running latest Android P. The Flutter app will always look and behave exactly the same. Same for when they are running on iOS devices even. Yeah, but it uses Dart, so Dart was new to us. So we had a look at that. Dart is fully open source, the complete project. Even the standard is an ECMA standard, so it's completely open, and it's around since 2011, so it has some really matured and stable core libraries. And on the language side, it has something modern approaches like lambdas, some nullability features like the Elvis operators. But in general, the language feature-wise, I would say, is between Java and Kotlin. The good thing is that you can run it in 2 ways. So it can be compiled just in time. So meaning run it, put it on the device, it gets compiled directly on runtime. And that means Flutter can use this feature to directly swap out the code that is running inside the app, which is hot reload. But it can also compile ahead of time to ARM native binaries. And that means it does that as soon as you build the app for production. And that means production builds are really fast and smooth. So Flutter apps have kind of become known for being really smooth. Yeah, and this is what, for example, a Google software engineer who didn't came from the Dart team said about Dart. He would like to who would like it to be a bit more feature-rich, that it can do more, for example, like Kotlin, but he had to say that he was directly productive after a day. And we, in our team, we felt the same. So Dart is that simple when you're coming from JavaScript, from Swift, from Java, from Kotlin, from TypeScript. You feel immediately at home because it's so easy. It focuses on familiarity instead of really big, complex features, and that makes it really easy to use. So, for example, this, if it really catches up, that can be a main driver for hiring people, because you can hire whatever guy you want, or women, whatever person you want, and it can be someone from web development doing JavaScript, from iOS development, from Android development. They will feel comfortable. Yeah, so we went ahead and built our app, the Jimdo Boost app. How does the GIF perform there? Could be better on this machine. Okay, you don't see how smooth it is. How old is this? Okay, anyway. Yeah, so as you can see, we built some really custom UI there. As said, it features our brand design, our Jimdo design, as we call it. And yes, there are some familiarities, of course, to iOS and to Android as well. But yeah, people that use this are coming from our web product, and when they see this, they directly feel at home. That was our goal. It's still very small and simple. It doesn't do much yet, but it's just a start and a most valuable product for what we do for our new product. And yeah, so far it's just showing some simple statistics about how the websites are being visited. But yeah, we have way more things planned for this app, and we're going to proceed with Flutter. So yeah, how we approached it, we took Flutter for a test bin for roughly 2 weeks with our 4 developers, built a small prototype, and in this prototype, each of our developers was meant to check out some certain features that we know are important for us, that we need to be working, so Flutter is no blocker for us. And so we saw there wasn't a big blocker, so we went ahead and built this app in roughly 3 months, including a completely new backend and approaching 3 different backend APIs, and yeah, also some conceptual back and forth with what the app should actually do. So yeah, it's maybe a bit hard to tell how productive we were with Flutter in these 3 months. But when we started, it was still in alpha, and with that we had several smaller hiccups with Flutter, but still nothing really big blocking. One small thing was, for example, that on iOS devices, in certain configurations of iOS, the Flutter system always provided the language English back to the Flutter app, although the device was configured to a different language. But as Flutter is made out of building blocks that are interchangeable, and you can really customize everything. You can exchange the whole localization system that the framework uses. So we wrote our own little tool there, our own little localization feature that used the Flutter platform channels, went to the native side of Android, checked the language there, and delivered that back to the app. And that was done in like half an hour before we even checked out if the issue was already on the GitHub repository, on the GitHub project of Flutter. So yeah, it's really easy to do. And you can be really fast with it. And things like that will come up, but they're not really blockers because the system is so open that you can exchange everything. Yeah, in general, feedback from our team, our Android developers loved it immediately because they feel directly home with the tooling, IntelliJ and Android Studio, and the results were also, before we even installed something, immediately nice for our Android developers because per default it looks like material design. But our iOS developers didn't love it as much at the beginning, but they're starting to as well. But yeah, at first the tooling was unknown to them, coming from Xcode, getting into IntelliJ or Android Studio, and of course the default was material designs, and that's also not directly what they wanted to have. But yeah, they are getting into it more and more as well because they see they are really productive with this framework. And also we even had some applicants that just applied to our company because we said we are using Flutter already. So that can also be some good thing in the future. And one thing we saw really usable when working with this new tool, and we had iOS developers and Android developers, is when, for example, the Android developers are developing some feature, let it be reviewed by the iOS developers. So they can check on their device as well and can also see if it's fine with how it works on iOS. Yeah, okay. Now I want to go ahead a bit and cover some topics that you're going to approach when you would go beyond a Hello World project in Flutter. So for example, how to approach REST APIs. Every app has to do that, basically. On Flutter, there's nothing like reflection. On Dart with Flutter, there's nothing like reflection. Dart itself has reflection, but it's not supported by how apps are being compiled for Flutter. But there is something like the Jaguar tool suite. It's roughly similar to how's it called, Retrofit and JSON. Of course, JSON uses reflection for Java, but Jaguar works a bit different. It's a dev time tool, so you have to put your mapping code, put your model code into the tool, and it generates some mapping code that you can use inside the tooling then on Dart. Yeah, some other topic. Yeah, we didn't use Jaguar. We went ahead and wanted to use Swagger because we in the mobile team had to build our own backend for this app. And Swagger is a tool where you can define a model and it generates basically the interfaces for the backend as well as for the clients. But yeah, there was support for Dart already in Swagger, but it was based on Dart mirrors, which is reflections. So it works with Dart web clients, but not with Flutter. So we worked the whole code generation for Dart in Swagger, and then we were good to go and build our backend with this, and you're free to use it now as well. So yeah, it's now inside the project. Yeah, some other thing I would want to highlight is the versioning of Flutter itself. Flutter itself, when it's installed or checked out, it's just a Git repository on a machine, always is checked out of Git for one specific version of Flutter. So each project you have on your machine then gets built against this specific Flutter version. That's of course not what you want. When you have several projects that you need to maintain, you don't want to keep them all updated immediately for each SDK version that comes along. And it's really bad when you share code between several people and they're working on the code. So to really have stable builds there, you need to pinpoint to one specific Flutter version that the project gets built against. We had it several times that some other developer that was gone for a few days then came back and the app didn't build anymore or behaved weirdly because his SDK version was outdated. So there's Pascal Welch, GDE actually for Flutter, who built this project, Flutter wrapper, just like the Gradle wrapper, and it pinpoints a specific Flutter SDK version to the project and then downloads, checks out from GitHub this specific SDK version when you try to build it. So especially when you work with several people and the CI use this. Then crash reporting. So there's no Crashlytics support yet, which is a bit sad because both is from Google. You could imagine that they would be talking to each other, but yeah, it's not there yet. And the only SDK for crash reporting we found yet was Sentry.io. Of course, you can use whatever tool you want and do your HTTP request with the crash data to that tool on your own, but we didn't want to write that on our own, so we looked for an SDK. We found Sentry, but this one is also a really simple SDK. It just gives you some methods to send something over to Sentry by providing an API key, basically. But there's nothing like on Android where you just have to add the plugin to the project and it will take care on its own to crash errors, to log errors, to catch them actually. So we went ahead and had a look at what do we need to do to catch exceptions on Dart. What we found is basically this. Flutter error, dot on error, you just set your listener there and it will get called for errors that are happening in the framework. And from there, we just call our own error handler and report it back to Sentry. Yay, done, easy. So we released that, and after 2 weeks or something, we thought there weren't any crash reports. So that can't be. It would be cool, but yeah, that can't be. So we had a look again at the documentation, and what it says was called whenever the Flutter framework catches an error. What does it mean? So, of course, when we saw it for the first time, we guessed, yeah, that's fine. But it isn't. It's really just when some call from inside the framework crashes. So your own Dart code with classes not directly running inside the framework won't be catched by that. So after some digging on Stack Overflow, we found this, basically. So you have to run the whole Flutter app. As you know, everything on Flutter is a widget, so also the whole app is. Run it zoned, basically, and that wraps the whole widget basically inside an error handling. So we are now logging in from there, and ta-da, we saw some crash logs actually. Damn it. But okay, our error handler looks actually like this. So when it's a release build, we log it to Sentry. But what's more interesting here is that also when it's a release build, and it's not an exception that comes from somewhere out of background processing, then we directly close the app. So in that case, we know the crash happened somewhere in the foreground, is highly possibly UI related, and with that can create a state for the user that we don't want to leave the user in. Because Flutter on its own, when it crashes, it doesn't crash the app doesn't close. Instead, it shows something like this. So that's really cool for debugging, but you don't want to show that to the user, of course. So that's why when we see it's not a background error that does something unpredictable with the UI, we close the app. of course, you want to keep that in debugging. So that's why we came up with the solution, because in debugging, when you use hot reload and you try out some code, put it on the device, you see this, because it didn't run, you can maybe directly see what was the problem, change the code directly, press hot reload again, and this will just go away, and the app will proceed where it was before. Yeah, okay. The biggest thing I personally think is a blocker for Flutter itself is that there is no background execution of Dart code yet. So when there's no screen around, no activity, you cannot execute any Dart code. It always needs a screen. And with that, when you, for example, get push notifications on Android, it's quite common that you get a push notification, you talk to your persistence or to your backend even, get some data, and then show the notification actually, depending on the data of the user. This way, you can't do that. You can do push notifications, but just when they are completely defined by your backend with some simple actions that directly go into your app. For example, custom actions on the notifications are also not possible because you cannot execute something in the background. They're working on this, but yeah, as a tip, keep your users' data maybe on native side. You want to use the account manager anyway. Some more things are like CI. We're using Travis CI with Fastlane. That works quite good out of the box. Of course, on iOS, it's a bit more complex with the signing there, but it works quite good. Then testing. Flutter supports unit tests, widget tests, and widget tests are really good because they're basically testing your UI like a unit test. So you can unit test your UI because your UI is basically an immutable tree out of widgets, and yeah, you can just test what data is inside these immutable objects like a unit test. But there's of course also integration tests where you can run it on a real device and instrument the UI. Localization was the biggest problem we had actually, because the tooling for localization is a bit sad, I would say, because you have to write Dart code that define your strings, run this through a tool that will generate some template files. You have then use these template files to create your own string files. Take all these string files, run it through a tool again, which generates Dart code, and the Dart code you can put into your app. So no one wants to do that, especially when you're coming from Android, for example, where you just have the string XMLs. So we created our own system, which is based on JSON and which just does some simple parsing for plurals or for placeholders. And we didn't open source that yet, but there's some good Medium article that describes exactly that as well. So someone else came up with it as well. So as I'm short on time now, mobile apps with Flutter. Regarding non-native UI, on Android, for example, material design is native. Same on Flutter, so you will be covered. For iOS, it's a bit more difficult because you have to then do some ifs inside your UI code and maybe use a different widget that then looks like iOS. They are also inside the Flutter framework, but you have to invest a little bit coding there. Then about the feature and update gap, it's maintained by Google. And even Flutter is a first target now for the material design team. So when the material design team at Google comes up with something new, Flutter is the first target to implement it in now. Then regarding system integrations for hardware integration, for example, there are platform channels, and these are really easy to use. They are basically like a JSON interface, but it's really easy to set up. It's directly integrated into the native side of your code that gets generated when you create a new project. So inside the Flutter activity where the whole app is running in, and there's also directly some APIs to use it on the Flutter side. Then regarding bad performance, yeah, when you build for production, it's compiled to native, so it can possibly even be faster than apps built against the Android SDK, because apps against the Android SDK are shipped in bytecode, and bytecode always runs on a VM. This is directly running on the machine. And yeah, hot reload is really a game changer. So the Android team also tried to do that with instant run, but I personally always turn it off because you never know when it works and when not. This thing just works. So it's really a game changer for when you are working with Flutter. So I would actually say it more looks like this then. So yeah, now with Flutter you can build something which is not as complex to do anymore as pure native. Of course, when you want to be really sophisticated and integrated with the system features, you will have to go a bit extra, but overall, the result will be quite like the native application, I would say. Yeah, and that's how I personally felt after using Flutter and coming back to our native apps that we are still maintaining. So I really felt like, what's going on here? It's so damn slow. It felt like working with my hands bound behind the back. It was like, what the heck? Is this really how I worked before? But yeah, so Flutter is really damn fast in development. So you're really productive with it. Yeah, I actually wanted to do some live coding still, but I guess time is out now. So yeah, thanks a lot. And yeah, I have to say this, we're hiring as well. So when you want to do Flutter, approach me. And yeah, otherwise, thanks a lot. I don't have my Android Studio here anymore. Otherwise, I would show some code actually. Yes. Are we good to go?
We have 2 microphones over there.
Thank you.
Thank you for your talk. Do you have any kind of approach how we can integrate C++ libraries in Flutter projects without maybe channels?
Yeah, so far there's no direct integration. I just looked it up myself yesterday because I really like ObjectBox, and ObjectBox is directly doing C++. So I looked up how to do ObjectBox with Flutter, but there's no way yet. They don't have. Of course, it should be possible somehow, but you have to dig really deep to make that running. So the only advice they give now is go platform channel, and from the activity, go C++. But yeah, then, I mean, you do the bridging again across Java. That doesn't make sense when you go native. Yeah, but they're working on it. More questions? Seems not. Okay, then thank you.